Friends, welcome back to my channel Robbie Jen Mac. Today, electric vehicles are very much in trend for the future vehicles, and I'm having one more new topic: electric vehicle power flow diagram. It is very important to understand how the transfer of torque and power will happen in electric vehicles, which are new for the industry. So, suppose if we talk about the IC engines is having very simple power and torque flow diagrams. Like engine is generating the power and torque, and it is transferring from clutch to the transmission to the differential gear, and differential gear to the wheels. So if we talk about the electric vehicles types, the conventional type is a very much important, like in which the engine is replaced by the motor, and motor is taking the power from the battery, and motor is providing torque and power to the transmission, and from transmission to the differential, and differential to the wheels. So this type of conventional type is very much important in automobile sector, where the speed of the vehicle and the gears are very important, and range for the speed is very high. So when you need different types of speeds and the range is very high, you need to provide the transmission to reduce the gears in the and increase the speed for the vehicle. So second type of electric flow diagram for the electric vehicles are transmission less type, in which, like, if you see, replacing the motor is replacing engine and transmission both. So motor is providing directly torque and power to the differential gears, and differential gears are providing to the wheels. This is generally used in the off highway application, where the speed of the vehicle is very less, or suppose like you don't need that much speed to the speed for the vehicle. So basically it is off highway equipments where the speed requirement for the vehicle is very less. The third type is transmission less and the differential less type electric vehicles, like in which, like, the motor, if you see, the motor is almost a cascade motor. So motor is placed on the rear side of the wheel. So it's placed in a single unit. So when during the turning operation, the both motors the both motors are running at different speeds to provide the differential action. So, and it is controlled by the vehicle unit. So steering is placed in the front wheel, and the motors are placed on the rear wheels. So this is the third type, which is also used in the off-highway application. If we talk about the fourth type, it is like motors with the hub assembly. So suppose the motor is providing some speed to the directly to the wheels, but you need further reduction in the gear to increase the speed for the vehicle. Then you have to place the planetary gear at the wheel assembly. So these two types of the applications are also there, like where like a motor is there, but it is directly placed on the wheel, or it is placed with the gears on the wheel hub assembly, that is planetary gear, for the further reduction of the gears and increase the speed of the vehicle. The fifth type is the motor with hub assembly on all four-wheel drives, like like two-wheel drive vehicle and the four-wheel drive vehicles on the engine sides. But this is like four motors directly placed on the four wheels. So, and the four wheels is having the torque and power to run the vehicle. So this, the advantage for the four-wheel drive in the motors is like compact in design as well as dimension, and reduce the power transmission losses, reduce in size and weight, develops a large torque and high maximum speed for the electric motor drives. So, like, how to select the motor is also a very much important topic. Like, if you see the electric vehicle motor selection, we should understand the power and torque characteristic for the motors. So if we talk about the IC engine, this is the torque curve for the IC engine. This is the power curve for the IC engine. So the torque is maximum at the middle side of the RPM range, and the power is maximum at the rated RPM. So if we talk about the electric motors, like electric motors is having this kind of the torque and power characteristic, where torque is constant up to the certain limit of the speed, then the power is constant throughout the range of the rated speed, or throughout the range of the vehicle speed. So if we talk about the constant torque, this helps EV motor drive for the high torque at low speed for starting and acceleration purpose. If we talk about the high power at high speed for cruising, which is required for cruising, and speed range under constant power is desired as wide as possible. So this range is also we can decide based on our motor selection as well as vehicle control unit or the motor control unit. So if we talk about the torque is reduced almost square times of the speed. If you will see this curve, it is almost decreasing with the square times of the speed increasing. So constant torque region would provide the minimum power rating for the motor. So this, like, it is used for this constant torque is using to give initial acceleration as well as pickup for the vehicle. So if we talk about the benefits for the power torque characteristics of motors used in electric vehicles, we should see, like, we can vary the range for the constant torque, also vary the range for the power region, constant power region. So the range of the constant power operation depends on the particular motor type and its control strategy, and maximum motor speed depends on the maximum vehicle speed. Acceleration time and acceleration distance decrease as constant power region ratio increases. So if we increase the constant power ratio, and so the constant torque region will decrease, so the initial pickup and acceleration will increase for the particular vehicle. So the rated torque for acceleration increases as constant power region as the constant power region ratio increases, drives motor size and volume. So totally it depends on the how you are selecting the motor as well as the vehicle control unit or motor controller. So it depends, like, how much wide range you should get for the constant torque, or how much wide range you can get for the constant power. So my next topic will be types of motor and selection, which I will continue with the next part. So today, if you like this information for the electric vehicles power flow diagram, please do subscribe and like my channel. And this is very important information. Actually, electric vehicles are very new to the market, and you should understand, like, how it is different from the IC engines. So thank you guys. If you like this information, please do subscribe my channel.